Why is a structured discovery phase so critical to the success of modernisation projects, especially in government and enterprise?
A structured discovery phase is really crucial to the success of a modernisation project for government and enterprise for a number of reasons. So firstly, we need to make sure that we know what we're building and we're satisfying the stakeholders. So that leans back into our process. So the process that we follow is Jidoka, and as part of that process, we always break our projects up into 3 phases. So phase 1 is discovery and design, phase 2 is modernisation, and then phase 3 is continuous optimisation. So for phase 1, and to satisfy phase 1 so we can move into phase 2, it's a certain level of things that we need to gather and collect as part of discovery to ensure that we know what we're going to do. So one of the key things that is the plan is something what we call the goals board. So the goals board is an application model on CodeBots of the actual project plan. And the way that works is we have our milestones. So we have milestone 1, 2, 3, 4. We estimate out at a milestone level. And within the milestones, we have different streams. So usually we have the application stream, the infrastructure stream, the platform stream, and then anything other, which is usually like documentation and things like that. Within each of those streams, we have certain goals that we set, and those goals are effectively the requirements that we want to build, and then they have acceptance criteria. What that means is that we have defined the requirements in a requirements model, linked it to the goals board, and defined the acceptance criteria. And the acceptance criteria is what the customer is going to sign off on to ensure that we're delivering the right thing as per every milestone. That's why it's so important.
Could you explain modelled requirements?
Yeah, definitely. So for the requirements, we put them into a requirements model, and then that's linked to the goals board. The requirements model traditionally in software development is actually abstracted from the project. What that means is that it goes into some kind of work management system like Jira or GitLab or something like that, or Monday.com, some kind of project management system, and they're actually abstracted from the product. But the requirements are the key thing as to what the product should be, right? So what we do is we put them into a requirements model, and that means that we can actually see everything that needs to get delivered and what the description of each of the requirements is. And an example of by putting it into a model, we can link it not testing model. Goals board. When we link the requirements to testing, we can also link it. We have a one-to-one relationship opportunities, and that means that every requirement's got the right tests. So there'll be both unit tests and end-to-end tests as per those requirements. But on top of that as well, once we've linked it to tests, we can actually use some cool systems like Playwright that links the tests to documentation. So from having the requirements as a model, we can get the tests, and we can also get the user guide and documentation of the system, all one for one, which is great. Now, when you update the requirements, you then update the tests and you update the user documentation. And it means that these things are no longer abstract artifacts that are siloed away somewhere, that as soon as someone goes and builds something, like becomes legacy. And then they come back to it in 6 months' time, a year's time, when the team's moved on and go, what is the requirement for this? We don't have it defined.
Could you explain built versus business requirements?
So when it comes to requirements, there's 2 types of requirements that we have when we're modeling. So the first one is as-built requirements. So because we're using modeling for the entity diagram and relationships and also tests, and also we link that to the behaviors, those other key artifacts. By us actually building table, the model of the user interface or the page diagram isn't actually an as-built requirement. We've modeled it, we've already built the requirement, and we satisfied the requirement. Therefore, there's no need for us to write down that requirement. So the separate thing is business requirements. And these might be certain flows or specific requirements that the business needs to satisfy the business process. And they're the ones that aren't as built. They're the ones that we need to custom code or do something else with. So those are the ones that we actually put into the requirements model. What that means is that we're storing less in the requirements model and we're leaning more into the actual models.
Could you explain like for like in discovery?
Yeah, so one of the things that we're really good at as a business is doing like for like modernizations. So when it comes to modernizing a legacy system, there's about 7 different options that Gartner recommends that you can do. So you can re-architect and rebuild it. You can re-platform it, so move it to a modern platform. You can rehost, and there's a number of things like that. The one that we actually recommend is re-architect. People often steer away from this because it's a bit harder, but we actually lean into it. And the way that we lean into it is through a like-for-like modernization. If you look back at our business process or our Jidoka stage process, discovery, modernization, and then optimization, those are the 3 key stages. The modernization stage gives us a like-for-like modernization of the present legacy system. Taking that view means that we get to modernize, but we remove a lot of the risks from the modernization because we're not changing the business process at the same time. If you're going to try and re-architect a system and change the business process at the same time, you're doing a lot of change management. You're changing the business process as you're changing the system, and that compounds the complexity effectively of a modernization, which is why a lot of modernization projects fail. So we say there's a simpler way to do it. You already have your business process because that is the legacy system. And you already have the legacy system, so now we can modernize it like for like, as close to like for like as possible, because when we're modernizing, we're going to update with modern architecture, and there's going to be modern standards like web content accessibility that the legacy system probably wasn't attuned to. So there's always a few wobblies along the way, but we find a balance in doing that. And what that means is, for the business, you achieve your modernization a lot faster with a like for like. And then you have control through the models and the modernized system to be able to move into continuous modernization. Great, you've modernized, your data's migrated, you're across to your new platform. Now you can go ahead and optimize. Change one thing at a time. Okay, let's change this process here. Where's the biggest opportunity for us to make an improvement? And then you can iteratively improve the process as the context around the environment changes.
How do we seek subject matter expert knowledge?
Yeah, so when we're doing a discovery and design, we always seek subject matter expert knowledge, because in any legacy system, there's 2 things. There's the legacy system itself, and then there's the knowledge of how that legacy system is actually used, and that's the subject matter experts. They're the people that are using the system on a day-to-day basis and know why they're pressing those buttons. 9 times out of 10, when we review a legacy system, there's no documentation, or there's very poor documentation, or the documentation is out of date. I can think of one time in the last 7 years where we've been asked to come in and review a legacy system, and the documentation has been 1 for 1 with the application. And what that means is brain drain has already occurred from the original production of the system to how it's being used now. And what that means is that people don't know why they're doing things, or on the other side, only certain people know why they're doing things. And as part of the like for like modernization, we need to be able to interview them to understand what their objectives are, and also look for those improvement opportunities that can be achieved later on. And that's why we always interview subject matter experts. The way we do that is we literally sit down with them and we record the screen, and we get them to actually show us how they use it and why they use it. A lot of the times it's pretty funny because people will come through and say, yeah, this is what I do. I follow this process here. I hit this button here. I hit this button here. I do this, do this, do this. Great. Now, why do you do that? I don't know. Literally, they just hit the button because it needs to happen. And it's amazing the amount of people that are out there doing that because that's what the business process says, or that's what they've been told to do. They don't know why. And we've had lots of cases where those buttons don't actually do anything. But they're doing it. Yeah, it's crazy.
Could you go into functional and non-functional requirements?
Yeah, so in discovery, there's two things that we want to do. We want to gather the functional requirements of what the system needs to achieve for us to modernize it, but then we also need to not neglect the non-functional requirements. So as one of the principles of our modernization process is to not neglect the non-functional requirements at your own peril. And a lot of the times over the years, we've focused too much on the requirements and not considered the non-functional requirements. So the non-functional requirements are all of the other things that sit around the system that need it to make it work. So for example, that is the infrastructure. How is the infrastructure going to be managed? Where is it going to be deployed? How is it going to be hosted? And on top of that as well, it's other things. So for example, for the Queensland government, there's about 5 or 6 different architecture principles that the system needs to align with. So for example, there is security, which is OWASP. There is the Australian Signals Directorate Top 10. There is also the Web Content Accessibility Standards and Guidelines. So for those 3 or 4 examples, how we manage the non-functional requirements is we have an information security management system. Our information security management system, which our projects fall under scope of, actually align to the Australian Signals Directorate Essential 8 and OWASP, which means that the products that we build are aligning to those security standards. And when it comes to Web Content Accessibility Guidelines, we have a number of Queensland government templates that we've built that are actually trained into cobots, which gives us a significant amount of momentum on the projects. So those templates are actually designed to be Web Content Accessibility 2.0 AA certified. Don't quote me on whether it's AA or not, there's a number of different versions. But within that, we can then actually report back on the security and also the functionality of the non-functional requirement of those to ensure that not only is the system delivering what we need from a business process, it's delivering what we need from a non-functional requirement. And another example of that is with the Web Content Accessibility Guidelines. When we do a release of the application, we use something called CI/CD. So it's continuous improvement, continuous development, continuous integration, continuous development, a pipeline that runs through and deploys it to the environment using infrastructure as code. When we do that, it goes through the Web Content Accessibility Guidelines standard test, and we actually get a test report that comes out that shows us our traceability in line with the guidelines. So there may be certain things, especially when you're doing like-for-like modernizations, that are not going to match the requirements, and we can know that and say, right, we know that we're not going to meet the requirements here. That's okay. We've made a decision and we've got traceability around that decision that that's okay. But in other cases, we can find the gotchas, and we can also validate to our stakeholders that, hey, the system's meeting the non-functional requirements.
Could you talk about the activities and workshops?
Yeah, so when we're in the discovery phase, the team will plan out a number of tech-activities, activities and workshops that we will do to understand the product and understand what it is that we need to build. So for example, tech activities are usually something what we call tech spikes. So they are a fixed time when the team will go through and investigate something that we consider to be high risk or something that we have little knowledge of. And if we don't have enough knowledge on that, or we consider it to be high risk, we say, right, we need to spend some time in a fixed period to go and experiment and play with what that thing is, so we can provide a better estimation, and we can also provide certainty to the project that we know what that is. So for example, if there is a legacy algorithm, we'll do a tech activity, which is a tech spike, to actually go through and just de-risk that, if that makes sense. Other tech activities are creating certain assets and models of the system. So a tech activity might be going through and creating the entity or the ERD relationship diagram, and then actually moving that into a workshop. So we'll go through, we'll create our hypothesis of what the ERD diagram is. So that's the database, all its entities, attributes, and relationships. And then we'll go into a workshop and we'll actually live model in the workshop with the business stakeholders and the technical stakeholders as to what that should be, and we'll update the model in the live workshop concurrently. In regards to other activities, there's certain other activities that we need to do, like the design and the business process. So we will do a review of the business process flows and review of the designs in workshops with the designers. Because we use cross-functional teams, those different activities get run by the different cross-functional departments. So the BA might run the business flow workshop, the designer might run the user interface workshop, and the solution architect will most likely run the ERD workshop.
What are some key lessons we've learned from doing discovery well and from getting it wrong?
Yeah, so over the years we have done discovery well, and we've also done it poorly. The difference is you usually don't notice if we've done discovery poorly until you're well into the project. So everyone is usually happy at the end of discovery, everyone feels like they have a grasp of the project, but there's certain things that we have done well or haven't done well, and that kind of is technical debt that accrues that we then start realizing into the project. That might be that we haven't discovered certain elements of the system, we've ignored the non-functional requirements, or other lessons are that we've actually lost knowledge in moving from discovery into development. So as part of our old process, we used to do a discovery and then would estimate and we'd provide that back to the customer, and there would be a gap between doing the discovery and commencing the next stage. And in that time, the team would disperse. And we'll go, right, okay, we're ready to go now. Yes, no worries, Mr. Customer. We'll reassemble the next best team that's available. And that means that certain stakeholders have moved on and there's not that concurrency. And when you do that, it was a big lesson from moving from having the same team deliver it, moving straight into deliver it. Great. Everyone's aligned, all the stakeholders know what was discussed and how it was discussed, but you bring new stakeholders in, you almost have to relearn the project on the go. And that happens whenever you bring anyone new into the project anyway, but having that happen as a whole team basis wasn't good. So that's why we now make sure that we book out the team for both discovery and development at exactly the same time, which was a huge lesson. Other lessons are that we focused too much on discovery and not clearly defined the requirements well enough. So that was a big lesson. So you need to get a balance right between the discovery and the design. Again, at the same time, if you over-design something, there is a common misconception that something is scoped. Nothing is ever truly scoped, because you get to a point when something's truly scoped means you've built the thing. It's a logical fallacy. So that's a difficult thing to grasp, in that there's a certain point where you get diminishing returns from continuing to scope. So you want to get a model or a rough idea or an estimate of what you want to build, and know this is close enough that we've identified the major risks, we've reduced the risks in the project, and we know what it is we're going to do, and we have confidence. Yeah. The other thing as well is that we often haven't allowed ourselves enough time to focus on building our non-functional requirements, which is the platform in regards to the code bots and the templates that we link into the project. So now we make sure in our first milestone that we have more time to allow us to do that, which gives us better momentum for the later milestones.